Now we've looked at the basics of getting these events sorted and these activities plotted out on our networks. We're going to get into the more nitty-gritty stuff. So the early and late event times, a little section for you to read on this before you start looking at these questions. So familiarise yourself with that. Have a little look at some of the examples that you've got in those notes. Some simple things that highlight in bold. The length of time an activity takes is called its duration. That's just English, isn't it? The early event time is the earliest time for the completion of the next event to start, and the late event is the latest time this can finish without having to extend the overall time for the project. So we're going to, instead of having labels for each event with just a number, we're going to create a little box, a little double box. We're going to have the early start time on the top and the latest finish time on the bottom. And we work our way through the network in order to do this. So if you've got your examples, I'll copy and paste them into here so you can see what's going on. So you've got your notes, which look like this. And then if we just go a little bit further down, we can start to look at how we calculate our early start times and our late finish times. So just let me paste that into here. If I can find my mouse, there we go. Let's make it a little bit bigger. Okay, so the activity network for a project is shown below. And this time you'll notice there's a little bit of a difference. Instead of having a 0, we've got two values, 0 and then another 0. So we call the number on the top, this is called the early start time. And that's the earliest the project A can start. Obviously at the start of the project that is 0. And if A takes 3, then the earliest I can start both B and C is given by this number here, 3. Because if it starts on day 0, B and C both require A, and A takes 3, that means I can't start B and C until A is done, until 3 hours in this case have elapsed. Okay, that's how it kind of works. And if you follow the route for B, 3 and 6 is 9, so we get a 9 here, so I can't start D until that's done, etc, etc. Okay, so that's how it works. So the top one is the early start time, the bottom one is the late finish time. Okay, and this is the latest a particular activity can finish in order for there to be no delay. So for example, this number here, I'll keep going in red, this number here, if A finishes later than 3, say it finishes at 4, that's going to delay the whole project because then B gets delayed, C gets delayed, and that's going to have a knock-on effect later on. Okay, we're going to get into the ins and outs of it all, but that's the basic idea between the early start time and the late finish time. So we've got to find W, X, Y, and Z here. So to find the early start times, so let's look at W to start with, which is here at the top. To find an early start time, you look at the previous event, or any previous events, you add the early start time, in this case the 9, with the duration, which is the 2, and you get 11. So W is 11. Now this one's nice and easy because there was only one event before this, one activity that leads into this, which is D. So there's only one option here, so it's got to be correct. But you're going to get it sometimes when there's more than one activity. We need to know how to deal with that. So there's W. X is here. Okay, now X is a little bit different because X has 3 different activities feeding into it, okay, into this event. Remember, the activities are on the arcs, they're the letters in this case with the durations, and the events are the boxes. So in this case, it's got to be a little bit trickier to find out. So we know W is 11, so I'm just going to put 11 in there very briefly so you can see. So all I'm doing is I'm adding on the early start time and the duration. Okay, so I'm going to get 16 here. But there are other ones as well. There's the 9 and the 4, which gives me 13. And there's the 7 and the 4, which gives me 11. So there's 3 different values potentially that could go in here, and we need to know which one is right and why it's right. When you're doing early event times, early start times, you're always looking at the biggest possible number. Okay, because if you think about what's going on here, although if I start at 7 and I do F, that means, yeah, at 11, which is where this number came from, you could argue that, well, if there was another activity, that could start at 11. But that other activity also depends on H being finished and G being finished. So I've got to wait for all three of these to be done. So the whole idea is that unless they're all done, I can't start whatever comes after X. In this case, it's the end of the project. Okay, so I can't start X without all three being done. So I've got to wait until the very last one is finished, and the very last one will be the biggest value. So when you're completing early start times, if there's more than one event like this, you work out all of them and you pick the biggest one. So in this case, X is going to be 16. Okay, that's how these kind of questions work. Then we've got Y and Z to do. So Y and Z are both in the bottom of the box. I'll put my 11 in now for W to make it a bit easier, and I'll put my 16 in for X. So this means the activity can be this project can be finished in 16 hours. Okay, and the late event time is 16, so we're always going to have the same. We're going to have 0, 0 start. Excuse me. And we're going to have the very same at the end. Now, when we're working out late event time, we always work out the early ones first. When you're working out late event times, we're working, sorry, it's not very easy to see, we're working backwards. So to work out a late event time, it's kind of the reverse. So if you look at what working out the latest Y can finish before anything gets delayed, we're going to look at the activities that happen after rather than the activities that happen before. And this time we're going to do the late finish time minus the duration. So that top one there going through E will be 12 minus 1, so that'll be 11. Okay, so which makes sense, because if Y is 11, if I just put that in here briefly, E takes 1. So if I finish the activity C at 11 and then I do E 12, it's not going to delay the rest, because the 12 and the 4 makes 16. It'll still finish on time. However, there is also another one going back into the event that Y is associated with, and that's 4. So I need to do the late finish time 16 minus the duration, which is 4, which is 12. Okay, and this time you might have guessed, or you might have worked out, you're actually going to pick the smaller value. Because if I say, oh yeah, 12's fine, well F is fine, because F will still finish, it'll still finish by 16, happy days, no delay. But if C finishes at 12, then I do E, that makes this 13, and then this 4 means the whole project won't finish till 17, and it's therefore being delayed. And these are the kind of questions they're going to ask later on, which is where it gets fiddly. But that's how late event times work. So we take the late event time of the activity after the event after, subtract the duration of the activity, and if there's more than one option, like here we've got 11 and 12, 11 from E, 12 coming from F, you take the smaller one of those. So in this case, we're going to take 11. So Y is 11, and in a similar fashion, I can fill this in now. Y is 11, you can just double check that everything works out once you've done it. Same when you do all the precedence table stuff. Remember, you can always go back and check that all the activities have the right things preceding them, and it all makes sense, it all adds up. So you can take your time with this. Dummies count for 0 because they're not really there. So here to find out Z, which is here, we're going to do 11, the late finish minus the duration, which is 9. And also we've got this activity at 12 minus 0, which is 12. So the one that is the most important for this, because there's two activities coming out of this box with Z in it. So we consider both of these, and we pick the smaller one, late finish time minus duration, which is 9, is our smallest one. That's how it works. So our Z must be 9. Okay, again, same kind of idea. If you pick 12, let's say we pick 12 and put 12 in here. Well, 12 plus 2. So if this finishes at 12 here, B finishes at 12. Then that means D can't start till 12. If D can't start till 12, it won't finish till 14. And if it can't finish till 14, G doesn't start till 14, which means it's going to be up to 19. So it's going to delay our whole project. So it all makes sense when you look at it, look at the results of what's going to happen. But the basic thing is early event times go from left to right. And if there's more than one, you pick the largest, which is a bit funny because you think earlier, why don't I pick the smaller one? But that's just not how the maths works. and then the late finish times, we go that way, and if there's more than one, we pick the smallest. That's the principle that we can do all of this in. Okay, and this is quite straight, should be quite straightforward marks really. You should be careful you don't miss any out by mistake. So that's question 1 done. Let's have a look at the next one. So question 2, I'm not going to copy the actual question out, but what I'm going to do is I am going to copy the network out. And they normally draw this for you, make it nice and big, because you're going to be writing numbers in here. So let's talk through this one. So this is number 2. So we start here. We're doing early event times first. So this box here has only got one activity before A. So we just do early event plus duration. We get 8 here. Okay, and we can pick either way we go. It doesn't matter here. This one has only got one before it, which is C. 8 plus 9 is 17. So we can fill the 17 in here. Okay, this one is a little bit different because I've got to make sure I've got this box, which is fine. That'll give me 17 plus 4. But I've also got to have this one. And because I don't have this yet, I can't consider that one yet. Okay, this one though, nice and easy because there's only one activity before it, which is D. So 8 and 7. 15 is the earliest this can start. Okay, now I can consider this one because I've now got the ones before it. F, the dummy counts for 0, remember. So 15 plus 0 is 15, so that's one option. 17 plus 4 is 21. Early event times, we pick the bigger one. There's no way I can start until F and this dummy, F and D, are done. And F is going to take the longer to finish because of C taking longer than D, and then F being on top of that as well. So it all has a knock-on effect. This one, 21 plus 5 coming down this route is 26. 15 plus 5 coming down this route is 20. We want the bigger one, but we've also got this one. So I can't consider this box, which I've now got circled, until I've gone the other route down the network. So we need to go this way. There's only one before this. 0 plus 6 is 6. This one, also easy. There's only one before it. 6 plus 5 is 11. So now we can look at this box again, because we've got all three predecessors. 21 plus 5, 26. 15 plus 5, 20, 11 plus 8, 19. So we pick the biggest one, so that'll be 26. And then finally, we've got this box. We've got two before it. 26 plus 5, 31. 11 plus 5, 16. Pick the bigger one. So we can't finish this until day 31 or hour 31. I can't remember the context of the question. So I always pick the bigger one. Okay, there's no point. Although K can finish at 16, well, it doesn't matter because all this stuff is still going on. So we need to wait for all that to happen. That's the idea. And then once we fill in our late finish time here, we can then start working backwards through the network. 31 minus 5. There's only one activity after this, so that must be 26. This box, we've got two activities after it. So we want to do 31 minus 5 this way, which is 26, and 26 minus 8 this way, which is 18. Pick the smaller one. So this must finish by 18. Okay, if it finishes at 18, K will still be fine, 23, that's fine. But if it finishes later than 18, say 19, 19 plus 8 is 27, 27 plus 5 is 32, and we have issues, it's being delayed. So hopefully we're getting the idea now. But you just need to learn the technique. I has only got one thing after it. So 26 minus 5, 21. If I'm going too fast, just pause it as you go along. This one's nice and easy, it's only got one thing after it. 18 minus 5, 13. This one has got two things after it, the dummy and the G. So we do 21 minus 0 is 21. 26 minus 5 is 21. They're the same, so this is 21. This box only has one thing after it, so we can do 21 minus 4, 17. This box has two things after it, so I need to check both of them. 17 minus 9 is 8, and 21 minus 7 is 14. So we pick the smaller one, which is 8, so this has to be finished by 8, and we are done. This just takes a bit of practice, you'll get quicker, you just got to be careful as you go along. Early event times, you're adding up, you pick the bigger one. Late finish, subtracting, pick the smaller one.